And welcome to Aughton Math. In this edition of Aughton Math, we're going to talk about how to graph a quadratic in intercept form. So we've talked about graphing quadratics in standard form. We've talked about graphing quadratics in vertex form. Now we're going to talk about graphing quadratics in intercept form. And the intercept form is simply, it looks like the factored quadratic form. It's just a times x minus p times x minus q. So let's take a look at what we're going to do in order to graph this particular quadratic in intercept form. Remember that sometimes we're going to use different orders in order to graph the quadratic, but ultimately we're going to find all the same points that we've been finding before, same points and same lines. So axis of symmetry, the vertex, the x-intercepts, and the y-intercepts. Okay, so let's take a look at our quadratic in intercept form. Y is equal to x plus 2 times x minus 4. Right? We've seen this many times before as you factored quadratics. So it's simply, we call it the intercept form. Why is it the intercept form? Well, believe it or not, the intercept form gives us, just like the vertex form gives us the vertex, the intercept form gives us the x-intercepts of the function. So the first thing we want to do is take what they give us and start from there. So step one is to determine the x-intercepts. The x-intercepts are p0 and q0. And if we take a look at the form y is equal to x minus p times x minus q, we can figure out simply that the x-intercepts are going to be -2, 0, and 4, 0. Right? So again, we're changing the sign similar to how we did with the vertex for the h value in the vertex form. We changed the value of at least this particular value in order to figure out what the zeros are. Now you have to be careful. When I say that, what we're really trying to find is the value that makes this particular factor equal to 0. So all you have to do is set x plus 2 equal to 0 and solve for x. You get x is equal to -2. If I had something that looked like this, 2x minus 2 times 4x plus 2, then 2 and -2 are not our zeros, because what we want is to use a zero product property, which says that anything times 0 is going to be equal to 0, to solve for this particular factor, these two factors, and this equation. So really what we want is either 2x minus 2 to equal 0 or 4x plus 2 to equal 0, because we know if those two, or if either one of those factors equals 0, then the equation is going to be true. It's going to be equal to 0. So we set 2x minus 2 equal to 0. We find that the 2x is equal to 2 and x is equal to 1. Okay, so in this case, when x is equal to 1, this factor is going to be equal to 0. In the second case, I have 4x plus 2 is equal to 0. 4x is equal to -2, or x is equal to -1/2. All right, so it's not plus 2. You don't just take this value. You have to solve this equation, equating it to 0, because you want the value of x that makes this particular factor 0. So x is equal to 1 or -1/2 would be the solution, or the roots, or the values of x that make the equation true, or that occur when y is equal to 0 and the graph crosses the x-axis. So all we're doing is we're finding the values where the graph crosses the x-axis by setting both of the factors equal to 0. And in this case, what we find is that x is going to be equal to -2, or is going to be equal to 4, positive 4. So our two x-intercepts are -2, 0, and also 4, 0. Okay, so we're going to go ahead and graph that. On the graph, it looks like this. I have an x-intercept at -2, 0, and another x-intercept at 4, 0. Next step. Okay, find the axis of symmetry. We know the axis of symmetry goes right through the two x-intercepts and divides them right in half. So all we have to do is take the average of the two values and divide, or average of the two values, and set those equal to x, and that's our axis of symmetry. So our p and q values are -2 and 4. I take the average of those two by adding them together and dividing by 2. So I have -2 plus 4 divided by 2, and I end up with a value of 1. So -2 plus 4 is going to be equal to plus 2 divided by 2, and that is equal to 1. So our axis of symmetry is going to be x is equal to 1. So I'm going to go ahead and graph that. I have x is equal to 1. I have my two x-intercepts. And again, here I've just shown you how to find the axis of symmetry. Okay, next step is to find the vertex. Well, we know that the axis of symmetry runs right through the vertex. So I have the x value, or the x coordinate from the axis of symmetry, and I'm going to plug that back in to my quadratic and intercept form and solve the quadratic for y. So I know the axis of symmetry is x is equal to 1. I use the value of x is equal to 1, and I plug that back in to x and solve for y. So I have y is equal to 1 plus 2, right? And you can follow along here as well, times 1 minus 4, which is the same as y is equal to 3 times minus 3, or y is equal to negative 9. And that's what we get here. So now I know that my vertex is going to be 1 for x and negative 9 for y. My vertex is 1, negative 9. So let me go ahead and plot that. I have 1, negative 9 as my vertex. So see, I plotted my vertex. I have my two x-intercepts. I have my axis of symmetry. It's looking like the graph is going to face up, but let's just double check, because that's, oh, we have to find our y-intercept first. All right, so step number 4 is to find the y-intercept. Again, you have to be careful. There's no identified c value, so we can do one of two things. We can rewrite this quadratic in standard form and use a c value, or simply we can set x equal to 0 and solve for y. So remember, when x is equal to 0, and sometimes this is counterintuitive, when x is equal to 0, I'm right along the y-axis. So I set x equal to 0, I solve for y. Now y is equal to 0 plus 2 times 0 minus 4, and I get y is equal to negative 8. So my y-intercept is going to be 0, negative 8. I'm going to go ahead and plot that. I have 0, negative 8 as my y-intercept, as you can see. I have my vertex, my two x-intercepts, and my axis of symmetry. I'm ready to graph, but again, let's just make sure that we have the graph going in the right direction. It's always a good strategy to check your work by looking at multiple facets of the quadratic. So step number 5, determine if the graph opens up or down. So if the sign in front of a is negative, it opens down. If it's positive, it opens up. The sign we see, the a value is positive. It's actually 1. Again, it's not stated because it is 1. It's positive, so the graph is going to open up. And finally, we're just going to use these values to finish graphing the quadratic. And you can see very easily, we just draw that red burgundy line through all the points that we've created. And it looks like I've missed the y-intercept as part of the graph, but it should go right through that. Y-intercept. And the axis of symmetry is x is equal to 1. My x and my two x-intercepts at negative 2, 0, 4, 0. My y-intercept at 0, negative 8. And my vertex at 1, negative 9. The a value is a positive value, so the graph faces up. It's a happy parabola, and I go ahead and graph my parabola.